All right, we're going to start recording. This is the SIG Auth meeting for Wednesday, January 25th. We have a few things on the agenda, and then we'll open it up. I think Mike had asked about talking about the per namespace DNS. So I'll stick that on there. We can talk about that. So first, just a quick update on RBAC status. V1 Beta 1 got merged to master, so that is available now and enabled by default. The API, not the RBAC authorizer. The rollout work for 1.6 is continuing. So kubeadm, Andrew, I forget his last name, new contributor, did a lot of work to get kubeadm able to set up an RBAC cluster and grant the right roles to the initial initial users and things like that. So that was great. COPS has the ability to turn on RBAC. I don't think it's doing anything else special to grant permissions to the various control plane components, but it's a good start. KubeUp on GCE will enable RBAC by default. I am working on enabling legacy ABAC policy if you use this to upgrade. So if you have a 1.5 cluster which was set up using ABAC and upgrade that, in addition to turning on RBAC, we would want to include the previous ABAC policy so that your existing control plane components continued working. And then I know GKE, some of the folks there are working on getting that set up as well.
Yeah, I was just going to pipe in. Have you given any more thought to my question about possibly allowing that as an option for a new 1.6 cluster?
I think the various deployment mechanisms are free to do what they want there, actually. I don't know. I think ABAC policy is legacy data, and creating new legacy data doesn't seem like something I would want to do, but I mean, it's an option.
I agree.
So,
and we're going to, encourage people to not do that. I just see the one, small set of users with the workflow of create new cluster, do some stuff, that this change will potentially break them. And if we give them a nice path, like, hey, this is the old way, keep doing it for as long as you want, but come do things the right way when you're ready.
Yeah, I think if we wanted an option to create a permissive cluster, I would rather see it be permissive using RBAC, just so that they could tighten it back up dynamically. I mean, that's what we will be documenting for RBAC, right? You start up an RBAC cluster, and you have your initial user, which is a super user, and then you can delegate permissions out however you want. You can slice it up per namespace. You can give some users power over the whole cluster. And so starting with one powerful user and then delegating is the normal way you set up a cluster. I mean, that's the right way to do it. And if the way they want to delegate is to say, you know what, I don't care, delegate all powers to everyone, then that's their call. That doesn't actually seem wrong to me to document doing that with RBAC, or give them an option to do that with RBAC. So,
yeah, maybe it's a specific to GKE or managed type thing. That's harder for us to undo programmatically. So if we are creating you a cluster and you want to run it the old way until you're ready to flip it to the new way, if we create a bunch of RBAC bindings for you and then you say, all right, I'm ready, make me okay. We don't know which ones we can delete automatically, and maybe it's fine for us to just say, all right, here's the RBAC policies we created. Go clean them up if you want to. I'm not sure. We can talk outside this meeting.
Yeah. One suggestion might be to label the things you create or annotate them.
Okay, I hadn't thought of that.
So if they say I want permissive RBAC, you can create roles and role bindings and label them GKE permissive role binding, and then reap them later if you want to.
Okay.
I didn't have a lot of other things on the RBAC. There are new roles being added. So as we roll this out and we find components that need permissions, we are creating roles for them. Those are in the repo under the Bootstrap RBAC package. We're also working on documentation for what those roles are and what they mean, and then the documentation for how you would, given a nice secured cluster, how you would go about granting access to people. So we're working on that. There's an issue about writing 1.6 documentation before the 1.6 branch is cut in the docs repo. So we're trying to work through that, but I expect that documentation to be somewhere probably within the next week. All right, any other questions, things people have been working on around the RBAC stuff, or we can move on to the DNS?
I had one thing, but I can wait till the end after we talk. I was going to bring up some stuff around the fine-grained namespace RBAC discussions that we were kind of toying around with, and just give a quick call for interested parties.
All right, this is real-time notes here. Okay. I think it was it Mike? Are you on the, do you want to talk about the per namespace DNS?
Sure. I was just madly trying to look up the RBAC documentation so I could make sure I'm informed and failing to find it.
Yeah, I will send you a link to or I'll put in a link to the open PR, which cannot merge because there is, yeah.
All right. So my memory of the existing RBAC design may be a little not entirely correct, but is relevant. So anyway, the DNS stuff is just one toe in this bigger waters of the multi-tenancy discussion we've been having. Mm-hmm. And I'm busily trying to use the existing abilities of Kubernetes, which allows outside-in multi-tenancy to be imposed, and just work out how to do what I want to do, whether I can do what I want to do, and contribute to the multi-tenancy discussion. So the thing that I've noticed from my potential users is they want what I describe as two-dimensional multi-tenancy. So it's not just namespaces and groups of namespaces. So the vision is I'm talking to developers who are working for organizations that are in the software as a service business. So such an organization has multiple SaaS offerings and multiple customers, and they're cross-cutting things. So a given customer of this organization may buy multiple services from the org, and for a given service, of course, there are multiple customers. So it might be natural to say, oh, well, we'll first do a hierarchy. So this has, say this organization has services and the services have customers, that loses the fact that it's the same customer, even if it's a customer of different services. You cut it the other way, but you lose the fact that it's the same service when it's accessed from multiple customers. So you really want the two-dimensional nature to be upfront and a priori, not try to hack it, pretend that a two-level hierarchy is a two-dimensional thing. It's not. So the trick is that the kind of accesses that they need to allow in one such organization, they need to control that can allow. So think of one customer of one service as having one namespace. And also for a given service offering, they typically have a central namespace that has stuff that's central, not specific to one customer. This is stuff that needs control over the customer stuff, and also has central services that needs network access to and or from the customer namespaces. And similarly, they also have some stuff that's specific to a customer but not a service. But it's still a two-dimensional matrix. And they need access between particular cells in this matrix. They need control in terms of the cells of the matrix. So that's just the awareness that I'm trying to bring to the party. And the problem comes up in DNS because I'm trying to figure out what, I made one simple proposal that was not addressing this generality. The proposal I made was kind of a baby step in this direction. And the reviews said, well, let's forget about the baby step. Let's just go where we want to go. So that's why I brought up my understanding of where my users want to go. So, and this applies not just to access in terms of who can look up what in DNS, it's also access in terms of who can access what in the API and who can connect to what in the network. Mm-hmm. So it's really, I'm trying to talk about the multi-tenancy thing in general here.
So, Mike, I was going to ask, do you think that in most cases, services, DNS, and network are correlated heavily in tenancy?
Yes.
Because I know, like, just knowing the DNS implementation top to bottom, this was one of the original things we punted on because of various, performance-related challenges. But, even in the very beginning with services, we said the idea of, we run very heavily multi-tenant clusters today, and we know that there's a fixed upper limit for services, and the fan out to each node for very heavy multi-tenancy for services is already a problem. So we had kind of assumed that at some point this segregation would have to happen for services namespace and DNS for sure.
I'm not quite sure I followed all the details of what you were trying to tell me. What fan out precisely were you talking about?
So to distribute all services and all changes to all services to all nodes is quadratic.
Right.
And if you are running at high multi-tenancy, so in some of our cases, we're running 10,000 tenants on the same cluster. The fan out for 10,000 individual services is actually very high. And so solutions which take into account tenancy of DNS and tenancy of services are good for very high density, high cardinality tenancy. I didn't know whether, do you see your use cases as more organizational tenancy or very, very small subtenant use cases?
Well, first off, I think in that fan-out problem, you're bringing in a dimension that I wasn't even trying to talk about, which is a node is hosting stuff from a variety of. I get a little nervous about the word tenant because it tends to make people think in one-dimensionally, and I really want to keep the two-dimensional or multi-dimensional view central. Let's say a node has stuff from multiple namespaces, but it does, given, as you said, a node doesn't really need to know about all services. It only needs to know about services that are relevant to the stuff on the, for example, kube proxy, right, only needs to know about the services that are relevant to the clients on that node. So I think an awareness of a structure like this could help filter out what a given node needs to know about. And
yeah, some of that is, I think some of the service catalog stuff, right now, the system doesn't actually know which services a particular pod is going to be using. The pod just hits DNS for it and gets directed there. And so having something explicit that is indicating that this pod uses this service catalog is interested in doing that so that the platform can provide additional assets, things like the credentials that you might need to use that service or configuration that you might need to use that service, but having that explicit indication that this pod is going to be consuming this other service, could be used by kubeproxy to limit what it's watching, though we don't have a good way for kubeproxy to sort of cherry pick. I want to watch these 1,000 services scattered across these 500 namespaces. We don't have an effective way to do that right now.
Which is
Right. I have two things to say about that.
Coincidentally, that's the topic that I was going to bring up after this. So we can come back to that afterwards.
But yeah, that explicit indication that I, in my namespace, am consuming a service in some other namespace, or in my own namespace, I guess. Just some explicit indication of that gives us a place to do things like hang policy, and say, we now have a way to decide, are you allowed to consume that? Yes or no? And then the components that are routing network requests and surfacing DNS. I don't know if that looks like per namespace DNS, or a DNS that takes into account which service references have been specified, so that when a request to the DNS server from a particular pod comes in, instead of just blindly saying, yes, I know how to resolve that DNS name, it would say, are you allowed to consume this service DNS name? So I don't know that a per namespace DNS server is the way we want to go. I think it might be a policy-aware DNS server.
So yes, I agree with that. That may be. I didn't want to get too deep into the implementation, but thinking a little bit about it and not being an expert on it, but it becomes clear to me based on the little bit of code that I traced. In general, when we watch something, I think you can watch based on one selector, maybe, with ands but not ors. But I think if we set up something where we can watch based on a union of selectors, and that's pervasive everywhere, I think that's the kind of thing we're going to need.
That's the next topic. That's okay. What that follow-up is. Yeah.
Okay, yeah, but we're getting ahead of ourselves to implementation. Let's just first talk about what we want.
One sec. So I would say, like, the observation that services are correlated to DNS. Can we think of a case where the DNS and the service proxy don't have that close correlation?
Look, I mean, you can imagine a lot, I suppose. I'm just going to represent what I know from what I'm hearing from my potential users. And I want to get back to a question I was asked about that. Someone asked me about something about large scale or small scale or something. So again, let me reiterate. I'm dealing with organizations. I work for IBM, right? And we have some big organizations that are in the SaaS business. They sell, pretty serious services, and they sell. Typically today, they sell to big customers, right? They want to get into the business of selling to more small customers. So such an organization has typically a handful of services, as many as they can manage with their develop and maintain with their development team. So, I'm hearing numbers on the order of maybe dozens, something like that, say, dozens of services in such an organization, currently with maybe hundreds to thousands of customers, maybe more, and hopefully wanting to be able to get to a lot more.
Okay, because and I bring this so from the OpenShift Red Hat perspective, like OpenShift deals with kind of three tenancy models. Cluster per tenant, commonly. That's kind of more like the classic, I own this entire cluster and I get to do what I want. But with potentially like weaker subdivision. So within that, I might have many different teams, but they all basically report to the same management structure. So if somebody really goes outside the rules, you just fire them. And the security boundaries are a little bit more classic enterprise IT security boundaries. And then there's the extreme multi-tenancy, which would be tens of thousands of one namespace per tenant, where a tenant is like some guy off the internet using containers. So that's like the OpenShift Online use case. Tens of thousands of individual users with very small amount of resources per. And then in the middle, we kind of also see that organizational tenancy. We're anywhere from 6 to hundreds of organizations using the same cluster, where the organizational admin might have a big chunk of control over the namespaces under them. or a set of resources with some segregation of security or all that. But that fine-grained role of, it's not just one a cluster and it's not just one per namespace, but it's in between. So we see the same desires from use cases. To the question I had asked about DNS and service proxy is, today the point of DNS inside the cluster is to answer queries about services and resources related to services. And we've tried to hold the line on how far we grow outside of that. One of the things that we have done in OpenShift is the kube proxy is the DNS server. And so when the set of services is filtered, or the endpoints that are visible for a service are filtered, that just automatically just carries over to DNS. Like, we don't use kube DNS for a lot of reasons, but that parallelism is very clear to us, that the same set of data, that if I want to proxy to this endpoint and there has to be a proxy that knows about those, I want to answer those queries from the same source. And what that had kind of led us into with Tenancy is solutions then that filter services down per node, or that filter endpoints based on what's reachable within a security context, then just naturally translate to DNS as well. Now, that doesn't solve the, can I ask another node for DNS queries? But there is kind of a natural, if the service proxy is the one who has to know how to reach out, and you can protect that, then you can do things like the DNS is only available from that node. And so you get the filtering at both sides. And that's been an avenue that we've explored for restricting DNS down to tenant level.
So
and
I'm talking about
DNS and network stuff has to go hand in hand too, because DNS is just the discovery bit. If you can go there directly, so the same policy has to be enforced both from DNS and in kube proxy. So
right. I'm a little confused by your discussion of nodes. I'm talking about a multi-tenant, first with sophisticated tenants, but multi-tenant cluster. So I can have pods from 2 different tenants on one node. I want to control access from each pod. Right,
and at that point, if DNS is being answered from the node and services are being answered from the node, you already have to serve. If you're solving the service tenancy problem, which is connections from X are allowed to talk to Y, then you've also solved on that node, connections from X are allowed to ask questions about Y. That's why I see those as similar.
Okay, right. So I'm right. Okay, you've got an implementation that ties the two together. I think maybe the question, again, I tend to organize things as first the API and then the implementation. So maybe the question is here, do we want to tie these things together in the API? And again, just speaking from the use cases that I understand, that I've been hearing about, yeah, the DNS is being used in order to look up services that are then going to be accessed in the network. So there's a correspondence in what should be accessible.
Right, and I know, does network policy, does that target services today or only groups of pods?
Network policy is pod selecting and it's only ingress.
Okay.
So I, in the abstract, it seems like either something like network policy or an extension of network policy to also address egress, and having that be able to be connected to the stuff that the service catalog is talking about, which declares I consume these services. So that if you declare you consume these services, then you can describe a network policy that says, because you just consume these services, therefore you may egress to those network addresses, and DNS would also respect that.
Egress is enforced down because it's how you control how you access the rest of the cluster. Ingress might be something that the tenant themselves can control, and service injection, in a sense, is a desire. Like when you say, like, I want to consume a service, the thing that goes in provisions the service for you is the one who knows what you're allowed to talk to, or has been granted that, or through some other process gets approval to inject and to open up that network flow into that service. So it does seem like there is a correlation there between the egress policy and that.
On this topic, we have debated in the network context the duality between ingress and egress, and there is someone who claimed there's a duality, and it's not exactly as neat and simple as you might think. But on this access business in general, I mean, if you focus only on intra-cluster accesses, it gets easier to talk about a duality. And I think I've been discussing this in terms of what I've tried to suggest in the PR, an approach based on namespace selectors and fine-grained delegation in RBAC. So the idea being that a user, let's say has access to namespaces. Suppose we can express this accessibility in terms of namespace selectors. So a user might have the privilege to access the namespaces that match a particular selector. And such a user could then grant or another user access to namespaces that match any subset of that selector. But you could turn it around, I think, and say, well, this namespace can be accessed by users that match a given selector.
RBAC doesn't do selector-based enforcement today. But RBAC doesn't do selector-based enforcement today.
Right. This would be an expansion of RBAC so that it could do some fine-grained, more fine-grained enforcement and delegation. What I was trying to make was that if we did it, I think we might have a choice between the directionality, right? Because ultimately, the control that needs to be expressed is between cells in this matrix that I'm talking about. And one way to think about it is for a new cell, what cells can it reach out to? Or another way to think of it is for a new cell, what cells can reach into it? I think you could maybe express things either way, as long as you get to use selectors to express a pattern to describe all the cells on the other side of this relationship.
I mean, we already sort of have something in RBAC that you can sort of say this particular user can see a service, for instance. So that seems like a logical extension that if you can see a service, you can hit it. But I don't know how well that falls into RBAC, because RBAC talks about users versus origin or something like that.
I will say that a service account is intended to represent the concept of what a pod can do. So in other contexts, we've extended this to say the service account is the one who has to be able to use a service. And service accounts, there's different opinions on where we want service accounts to go, but as the concept of it's the machine entity that's running, regardless of whether we eventually add something to service accounts like delegation, which is the service account is running on my behalf, it was the original intent that the service account would represent that identity for the purposes of RBAC. We started down that path a little bit with secrets and then backed off while other stuff came to fruition. But for pod security policy, for instance, the service account is the one that has to ultimately have the permission to, has to be bound to a policy that allows it to run. So I would not actually say that I disagree that there might not be some mapping between a service account and the network or the set of networks it's allowed to access, because the pod is not the one who has that authority today, at least in the way we've talked about it so far.
That seems like a pretty low overhead way of getting these type of policies then, if we're talking about pods needing to access other services.
Do we
observation?
Do we want to just jump into the link I docked almost directly talks about namespace selectors, and I wanted to go through the use cases that have come up and some of the ideas just so people here to think about it. Mike, did you want to keep going down this vein, or do you want to talk about namespace selectors in particular?
Okay, with me, if you want to talk about namespace selectors, yeah. I think I want to think more because it's true that the current network policy is not oriented exactly the way I'm talking about. So I want to think about how I want to move that forward.
All right. So let me, I pasted the wrong issue in, sorry. Fixing bugs. I'm going to paste this right here. So we've been having a discussion in 3 or 4 different veins. I'll linkify it. We've been having a discussion in 3 or 4 different veins around sub-selection and organizational tenancy on our side. And I think this kind of gets a little bit to Mike's point. So let me share my screen. Who's sharing right now?
Oh, I am. There you go.
Jordan. So David and Jordan and I kind of punted around a couple ideas recently, but we talked about organizational multi-tenancy. So on OpenShift, we'd like to introduce organizations. We already have cluster resource quota that eventually I think will make it into Cube, which is a quota that applies to namespaces by selector. So you can say this organization gets access to 700 cores, and individual namespaces might have their own limits. But for instance, if you wanted to slop quota across 700 cores across 15 namespaces, that's a use case that we hit pretty early. And so we started there rather than starting from an organization and working backwards. We started from building up tools that allow those higher level concepts to be expressed. So with organizational multi-tenancy, we had kind of already been naturally thinking in the idea of namespaces being label selected. And just for grouping, as an administrator, if I was an administrator looking at a cluster and there's 700 namespaces and I wanted to say 100 of these belonged to an organization, probably the natural way for me to do that would be to label select them, right? That's what label selectors are for. That gets into a couple of things like who's allowed to change those label selectors, which we really haven't dealt with, although there have been a number of proposals over the last couple of years on that. We do have sparser multi-tenancy cases, which is kind of like what I was talking about before, where an individual might have 1 or 2 or 3 namespaces. And those kind of tend to be granted individually. So that's like the self-service namespace model, where instead of letting any user create a namespace, you come up with some sort of self-service portal or some sort of flow that allows someone to say, I want a namespace, and we give you one, and it has a quota. And that worked okay for OpenShift for the first year and a half. There's different patterns there, right? Like you can do it with a self-service portal. You can call the API as a higher privileged user. Or you could come up with a quota system that says, hey, every user is allowed to create a namespace, but then you have to get into ownership of namespaces, which requires some sort of metadata to track that. And so we never really talked about quota of cluster resources on that vein yet, but it is something like if you can create namespaces and those namespaces have a quota, then you still need a way to limit that. So for now, we just assume that's a higher level thing that goes and creates namespaces, so the programming down. And with both of those, there kind of comes to this case where we start talking about scoped integrations. And so a scoped integration would be, I want to go build an ingress controller and use it on a tenanted system. Well, the system administrator is not going to give me read access to secrets across all namespaces. And for instance, ingress controller today requires read access to all secrets, which is like, I don't know that that's even something that we would allow to happen on a cluster, for instance, because a service account secret stored on the platform that grants access to, for instance, a controller that's allowed to do anything on the cluster would mean that it's a very easy hop from the ingress controller being compromised to rooting the entire cluster. So with these scoped integrations, we've been trying to think through, if I own a few namespaces, or if I own a chunk of namespaces, and I want to build an integration that I grant access, am I going to do it by granting access to 10,000 namespaces or 500 namespaces or 30 namespaces? It's possible. But if I did it on a per namespace basis today, the only way that we would be able to implement that in Cube, as Eric pointed out, was we have global scope and we have namespace scope. Those are our 2 scopes we support. And we can't efficiently, we would need to efficiently solve some variant in between. Label selectors on namespaces or label selectors on resources themselves at the cluster scope is one option. So when we were talking about this, if you think about if I'm an ingress controller and I need to access certain secrets, I need a permission that scales out, right? Like every individual user needs to grant me permission, me being the ingress controller, hosts account permission to go access a specific secret. So one way to do that is to create one RBAC rule and one binding for every single secret that wants to be exposed. And there's some scaling problems with that. Another option would be the user can opt in to exposing that secret by giving that secret a label selector that the ingress controller has access to. And so we've been kind of playing around with some of these ideas. I don't think in no way are these baked, but thinking about this as what is the level between cluster scoped and individual name and namespace. So basically, like the idea might be label selection of some form, or of calculating indexes of what permissions you have on individual namespaces. In either case, the rest of the issue is really a discussion of what's there. But I think to your point, when you come at this from the other angle, programming down works great until you want to make API calls against the master to efficiently do multiple namespaces, and then everything falls over in our current model. So I think in the short term, one of the questions I want to ask this group and from an engineering perspective, get ideas flowing is, if we ever want to have a integration that doesn't talk to the whole cluster, we probably need a set of common mechanisms in place to enable that, whether that's RBAC or efficiency in watching or efficiency in listing. Like it's going to happen. And so I would like to, I want to get at least the discussion moving so we can talk about it in the, over the next.
Well, I think it's obvious that no matter what else happens, you've got to have, it's all going to rest on watching. So you've got to have more efficient watching.
Yeah. And the proposal, the issue kind of talks about some of how you would do list watching, but it's actually not just watching, it's listing then watching is what has to remain consistent. Otherwise, everyone has to go rewrite all their controllers.
Right.
And so that kind of, I think it's solvable. Like David and I kind of tossed around some ideas. There's some hard problems in there. Various people have experience with this, like in, from enterprise access control systems that they worked on in the past, or, it's not, these aren't impossible problems. And it would be, do we think it's important enough that in the short term we would invest in that? Probably. And I'd be interested in knowing who else kind of has this problem today. Mike, I know you do. Is there anybody else in the community who is also interested in kind of the idea of subdivision of watch or subdivision of listing at a granularity less than a cluster or namespace?
Above the namespace level, but below the cluster level.
Yeah, and I think the secret integration one I threw in there just because it's kind of a weird one where I want to let users opt in to exposing their secrets, and we can do that through RBAC with many, many different RBAC roles, but that one's almost like a specific set of resources within a namespace. But you're right, it's basically between namespace and cluster.
I mean, really,
I think we have this. I think from a Kubernetes perspective, we are just now like 1.6 starting to get to the scope to a namespace. Starting to make that even be practical to do. And so I want to get that solid, knowing this is coming, but first things first.
Yeah, that's the other thing too, is like, don't see this as like, I'm going to go ask people to go do this. Think of this as, this is where, like Mike, to your point, as we make this path forward around tenancy, think about the prereqs that we're going to need to get there.
Yeah, just because it'll take multiple releases to get those mechanisms through the API and storage layers. I think some of the storage proposal was talking about more like richer indexes on top of data, and then just the mechanics of how you would express, authorization aside, like just how you would even express, I want to watch this subset sliced in these 2 dimensions.
Yep. Yeah, and the secret thing is really blowing up right now for us because people are finally realizing that secrets are secret. And so I think like there have been other discussions about secrets, like people want to integrate them from the outside in with something like Vault. service account tokens being commingled with end user secrets is something that there have been various discussions about trying to tease apart. When we talk about some of those solutions, I think it'd be useful to keep in mind, like, ingress controller is a really pragmatic one right now because it essentially requires root escalation of the whole cluster. But all of the sub problems around secret subdivision basically boil down to service account tokens being in the same space as the rest. And so, thinking about how we would subdivide secrets on the cluster.
Yeah, it's not just service account tokens. I mean, you want your serving certs for ingress to be segmented from your image pull secrets for your build pods, segmented from your API tokens. Like, everybody wants their own bucket, and we don't have that today.
Yeah, so there is no proposal today for the secret subdivision, but I do think various folks have issues and things tracking across a wide range of SIGs right now. So it's useful also for this group to be thinking about where their use cases intersect.
Okay. Let me give Caleb a minute to talk about the last item on the agenda.
Cool. Yeah. So Sarah has been asking for SIGs to give updates to the community meeting, and I am wondering, we have the Contributor Experience Working Group going tomorrow. I was wondering if SIG Auth would be willing to prepare a brief summary of the things plan to work on during 1.6 at tomorrow's meeting.
Yeah, I actually was planning to join and talk about the RBAC rollout, just because that's starting to get to the point where people have the ability to enable it in their deployment mechanisms. So, yeah.
Great. I will add you to the agenda then.
Okay. Oh, one other thing to mention with RBAC, CubeMark just started enabling it. And so CubeMark is now running the scale tests with RBAC enabled, and saw a little memory bump. I think it was like a 1%, 1.5% memory bump. But scale tests are running with it on, so that's good. That was the scale testing was on one of the big things on the way to B1. So. And yeah, for the isolation thing, the API machinery, getting them involved early for the mechanisms, and then the SIG network and SIG Auth for kind of the API and the network dimensions. I think it would probably be worthwhile to set up a meeting once we kind of have specific questions. Set up a meeting where we pull in people from all of those, talk through things together. But yeah, we can kind of group around the poll that you had, Mike, or the namespace organization one that you opened, Clayton.
Yeah, I think there's probably, we should probably create the secret subdivision tracking issue just so that we start having a place to cover it, unless someone knows of one that already exists.
I haven't seen subdivision mentioned. The injection of external ones and encryption at rest are both open, but the subdivision one I haven't seen mentioned.
Actually, so one point on the encryption at rest, like, I do think we're going to try and push that. So Daniel had asked for reviewers and nobody spoke up, but I think I'm going to put myself on that reviewer list just because it's coming up more and more for us. So if there's anybody else on this SIG who cares about encrypt at rest, I would recommend getting involved in the proposal. I was trying to scope it down to something that could be quickly pushed through in a sense, in the minimal sort of feature that would be necessary to do encrypt at rest of just secrets efficiently.
Can I also beg, whenever we talk about encryption, really the hard part is the key management. So being explicit about who has access to the keys is really the key to the whole thing.
Yep. What was the other one? Okay.
So Clayton, I was going to just comment in your or in your issue, but maybe I'll bring it up here real quick. The scoped integration piece of what you were just talking about makes me think of discussions we've had about per kubelet permissions and limiting kubelets to.
That should be on there too. Did we actually ever open that issue, Jordan?
I'm sorry, I was typing. What?
The subdivision of secrets, subdivision of node roles, the node authorization case.
I know we have issue tracking it. I think we've actually been pointing people at our issue, so I will make sure one is open for that.
And that was CJ. Correct me if I misunderstood, but that is the ensuring nodes have only the permissions that they require in order to affect their action.
Right. The most important one being secrets, but also simple stuff like nodes don't really need to see all pods in the system.
Yeah, the two that I care the most about are read access to secrets and write access to pods. So a node should not be able to create or mutate pods assigned to another node.
Yeah, and I think for us that one is also increasing in importance, although we've punted on that long enough. I mean, CJ, I don't know, do you also see that as a near-term priority for you, or do you think that's kind of just you want to be aware of it?
I see that as it's going to come at us in 2017.
Yeah, I've been amazed that we've danced as long as we have around not having this, and it's mostly because people are trying to get all the other, like to Mike's point, you're trying to get their secret management in place for the root credentials and then moving up the stack.
Yeah, at least in like the GKE and GCE world, we've stuck in the cluster as the security boundary land for far too long, and now as we're poking at actual pod granular permissions, people are noticing other things.
Yeah. Just a small amount of things on the plate for SIG Auth for 2017.
All right. I appreciate it. Anyone have any last minute items they wanted to talk through? We got a couple of minutes. Did we have a couple cherry picks going into 1.5? Eric, you had the client side one that fixed the OpenID Connect performance issue.
Yeah, I still think that's waiting for the cherry pick master or whoever that is.
So that will help with client-side performance, make that actually usable. And then David had one that fixed the request header proxy so that it would correctly prompt for client certs. And I'll put in links to that. All right. Well, that's all I had. Appreciate everyone's time, and we'll see you in 2 weeks.
Have a good one.